So I was like, okay, there must be something out there. So I had a look, and I was like, oh yeah, there's a couple out there. They're pretty expensive. You've got a few. Fat Shark do one, I think, or Immersion RC. One of those guys do one that actually has the sticks on it, and it is quite a small form factor, which was the other idea. You know, it's like it needs to be lightweight and it needs to be sort of fun and easy to chuck in your bag. So yeah, I was like, okay, well, what else is pretty cool? You know, Steam Controller was released recently. That looks pretty neat. Will it do the trick? It's a bit flaky on Bluetooth, so don't want to trust, you know, a quadcopter flying at 150 k's an hour to Bluetooth and a wireless link, and something that is actually on that same wireless channel. So I was like, okay, let's think of something a little bit more discreet and try to figure something out. So I actually had a look at the touchpads, which come from that Steam controller, and so they're Circ touchpads, and you can actually buy them at Mouse, which is pretty easy. So $12 each, and I thought, yeah, I'm just gonna make a board. And for the board, you know, not gonna bother with using sort of a custom solution, because you know we've got an M5 stack, we've got a display, you've got everything you need, battery charger, you know, you've got a boost converter as well, so it'll do the trick. So chuck that together, built and printed a 3D case. So it's got a port here for the standard JR style RC transmitter. You just plug it in and off you go. Luckily I've been able to do most of my testing using a simulator. Running dodgy code on real life hardware that could potentially injure you is not ideal, so it's pretty good just to, you know, plug your quadcopter into your laptop and just directly connect to it like that. One of the interesting things I've actually had to do with MicroPython is use the, and actually not only with MicroPython but with the ESP32, is use the RMT module. That is a pretty good way to get the PXX protocol, which is what communicates from the radio or from the M5 stack to the radio. It's a pretty good way to approximate that, since the PXX format is just ones and zeros made up of different timing bits. Yes.
What's the RMT module? I'm just like for everyone. So
yeah, what is it?
It's a blob of silicon that's on the ESP32 that allows you to batch up like a sequence of ones and zeros and then spit it out at whatever timing you want. And so for this device, which had like a one-wire interface, it seemed to make sense to use that. So
that's it.
we don't yet have a general solution for that yet. A lot of that part of the system here is in C, and Raf's got like a little interface that's sort of custom built for his application. But eventually, we'll turn that into a regular MicroPython module. You'll be able to send out your own sequence of ones and zeros.
Yeah. And so that, I guess, was another interesting bit to delve in, sort of getting the build environment working for MicroPython, so you could create that C module and expose that that part of the ESP-IDF and pipe it in. So it wasn't that difficult. There's been a lot of stuff done in other, I think CircuitPython has one, or was it
No, Icon guys.
Yeah, and Lobo.
Logo as well, yeah.
Yep. So anyway, there's enough information out there, so it's fairly easy to do, and there's information on how to actually write the module as well. So it's pretty cool. And so far I've got it flying outdoors with my quadcopter. It's still a bit flaky, still a few things to fix, but it's really fun to fly on the sim. So yeah.
Cool. Thanks, Raf.
Good.
I guess if anyone wants to, you can watch Raf flying his sim a bit later. But yeah, it's pretty snazzy. It's pretty cool. It's all hanging together. It's in a fairly short amount of time, really. But
Yeah.
Ooh.
Back to you, Matt.
Sure.
Thank you.
Good work, Raf.